Welcome to data analysis with Python. And this is the second video as far as data analysis is concerned directly. But of course, if you check the playlist, I have videos 2 to 13 brought from scientific computing with Python because they are basically the same, like setting the foundation for Python and also taking us through the whole process of NumPy. And for to be a good data analyst, using Python, right, you need to, of course, master the basic ideas of Python. Then you need to understand NumPy, and all of those have been covered in the videos 2 to 13 uploaded after the introductory video. So this video. I'm numbering it like 2A because it's the second video that is directly connected to data analysis, and this takes us straight to the idea of pandas, right? So let's go into what we have right here as we begin to use pandas. Uh, pandas is basically the library, the Python library for data analysis. So let's go into that. Okay. So first of all, we start with the types of data. And from what you can see, we have two types of data. Of course, types of data can vary based on what you're thinking about. You can think about types of data in terms of how the data is sourced. If it's a data that is generated by yourself, in statistics, we know that's like primary data. But if it is from another source, you can say that's secondary data and so on and so forth. But in this context, we are looking at it in terms of data science and all that. And then we have structured and unstructured data. So of course, structured data is data organized into rows and columns. And examples would be like CSV, that's comma separated variables. We are going to learn more about this as we go on. Microsoft Excel, of course, that's like I said, everybody interested in data should have a foundation, a background in Microsoft Excel. And then we also have SQL tables. Then apart from that, we have unstructured data. That is data with no fixed format or structure. So like it's just all over the place. Like when you have text files, HTML, PDFs, images, social media posts, they are not structured. They are just they don't have any fixed format or structure. As a result of that, it's difficult to say, bring me row one, column three. So we talk about data sources. Where does data come from? So, like I said in the first video, in the introductory video, right, that data can come from three main sources. So it can be self-generated. I mean, when we talk about Python, that is, so it can be self-generated, maybe from your personal research or your study or your survey. So an example would be you generating data programmatically using lists or dictionaries in Python. So if you go through videos 12 to 13, 2 to 13, you would have seen ideas about lists, tuples, dictionaries, sets, and all of those things. So you can actually generate your own set. For instance, I just want to quickly create data of maybe three of my friends. One is Awasu, the other is Bobola, and the other is Chukuma, and they are aged 24, 30, 22, and they live in New York, Abuja, and Perth. So I can just quickly create that by myself. That's self-generated. If I run that, it just gives me this output here. So of course, by now you already understand how to move around Jupyter Notebook as seen in the second video after the introductory video, the video next to the introductory video. So you can have self-generated data, that is data that you impute yourself. Then you also have some data inbuilt in Python. So you find them inside of Python. So you can load sample data sets by Python libraries like sklearn. There's also Seaborn, all right? There's Seaborn, we are going to say Seaborn when we talk about data visualization for sure. So, so many more. So, but you can get data set from sklearn, scikit-learn, and Seaborn, and so on. So, you can load sample data set provided by Python libraries. So, those data sets are inside of Python libraries, okay? So for instance, you can take from sklearn.datasets. So if you're using sklearn, so you have data set inside of sklearn, you can load iris. In fact, if, for instance, in C1, I think it should also be the same for sklearn too. You have some data set that are inbuilt that are used for, many tasks in machine learning and all that. So one of it would be iris. Iris is not talking about the eyes in this case, it's talking about iris flowers with three species and 50 flowers each, and their measurements are taken for the length, width and all this petal length, petal width, sepal length, sepal width, and petal width, and things like that, right? For those iris flowers. Then another very common one is the tips data set, talking about how people give tips in a restaurant and how they go to that restaurant from Monday to I think Sunday and all that. Then there's also the Titanic data set, talking about the people on board the Titanic ship when it sank also. Then I think there's a fourth one, flights. Yeah, talking about flights from, I think from 1960 or something, for over a period of years, basically. So those are all inbuilt data sets, in Python. Okay, so for Iris now, so we are saying from sklearn.datasets import load iris. Okay, so load the iris dataset from sklearn. So iris, say load iris, then you call the data frame. So that gives you shows you what the data frame looks like. So now by now you know that Python numbers from zero upwards. So it doesn't start from one, it goes from zero upwards. So sepal length, sepal width, petal length, petal width. Normally this head is whenever you see head like this, it's showing you the first five. But if you want to see the last five, you do tail. You say that head that whatever dot tail. Okay, so these are the last five now. Showing the sepal length, sepal width, petal length, and petal width, and so on and so forth. Okay, so let me take it back to head. Or if you don't want the head, you want everything at once, which is not possible though. Once you have more than 50, it shows you the first five and the last five. So that's also another thing to pay attention. So we are going to see more of this as we progress, right? Um, so that goes five. So we also have self-generated data, Python data set built into Python, and you have external sources too. So external data from external sources are data sets not created within your script or bundled with Python, but accessed from the outside world, such as Kaggle. Kaggle is a very popular database for data sets. So it's a platform for data science computations and public data sets where you can download CSV, Excel, JSON files and load them into Pandas. Don't worry if you don't know what CSV and Excel and JSON. Of course, I think everybody listening to me should already know Excel. But of course, CSV, JSON, I'm going to talk about them better as we move on. Now, by now, I think in my previous videos, I didn't tell you, I couldn't really tell you what raw was about. But if you need to write a code, that's what code is for. Markdown is for when you have to write, maybe when you have to write equations, when you have to write something like this external sources I did here with this hash representing the highest level of headline. So, with this now, if I run this, it shows me this. But here, if I put it in code format, all right. So normally it should be in code format, but because there's nothing like Kaggle data set. This is just a generic thing. So if you have an actual data set, you can put it here, and you'll understand how to do that as we progress, right? So if I run this now, it's going to give me error because there's really no data set called Kaggle on the data set, and because I don't want that to happen, I have to make it raw. So if you want to type something in a cell, I don't want it to appear exactly the way it's showing. I mean, if you want it to appear just the way it's showing, you don't want it to run, you don't want it to be like a markdown. So you just put it raw, and that it will just show whatever you type, it just comes out like that. For those who use what's this thing now? LaTeX. For those who use LaTeX, it's more like when you say something should show verbatim, that's what that is. So you can also have data from the external data sets like Google Sheets, convenient for collaboration, and it acts like an online Excel sheet. You can access Google Sheets as a CSV via public link or API, like that. So, and of course, again, so if you want to do that, of course, if you have a particular link, a particular Google Doc link, you can just paste it here, and then you can just paste it in this highlighted place like this, and then it can now work. But because if I put it as code now, it won't work because that link is just it's not an actual link. It's just an example. So if you have a proper link, you can do that. Okay. So this goes. Okay, yeah, I have to put it back at raw. If I put it at markdown, it doesn't come out quite well, so it just scatters everything all over the place. But I don't want it as markdown, so I can click it back and then make it raw. So it just shows exactly the way I have it there. Okay. Yeah, so you also have open data portals. open data portals provided by government like NGOs or research organizations like data.gov, World Bank data, UN data, and I think the world in data. I think there's also a page like that, you know. So in this case now, we're using, yeah, somehow I've forgotten what API is. Let me quickly check that out. API, um, API is application programming interface, exactly. Application programming interface. Show results in English. Application API meaning, yeah, application programming interface. Um, a software intermediary that allows two applications to talk to each other. So one application talks to another application and then they give you an information. So it's also a very good source of getting data, right? So we're going to see something about that soon. So this is a World Bank kind of data, and we just want to see the date and the value. Right? So you just get the link of that, the JSON data or whatever the format is. And then if you run this, so it goes to the website and extract data from there. So in 2024, there was no value, but from 2020 to 2023, we had data. But 2024, no. I suspect this is about COVID. I'm not sure, but we are going to see more later. So another external source will be web APIs, like we saw application programming interface. That's so you have uh you have an application, say Twitter, communicating with a weather service to give you weather information. So that's what APIs are about. So many services offer JSON-based APIs, e.g., Twitter. So Twitter can give you application programming. Yeah, I think Twitter even has a special program. I think it's called X now, right? So let me change that immediately. It's now X, not Twitter anymore. Okay, so Twitter, I think X has that program where I think you can even apply or something if you use data, if you do some web, is a web scraping or some scraping as you're going to see next. So you can actually get information from different sources, as Twitter or X helps you to communicate with those sources. So this is, something, a very good example of that. Now, so if you have a proper link, so you can just put it and then you can actually bring information from web APIs. Then another source, last but not, I mean, it doesn't mean that that's all we have, right? But I've given these examples. So web scraping, like you can actually do web scraping for HTML tables, where you extract tables from websites using pandas dot read underscore HTML. All right. So you can do web scraping. For instance, we are scraping the FDIC web page now. I think that's some financial institution. So we click on this now. So then it shows us bank name and all that. As you're going to see later, if you want something finer, you can just remove this head now and remove the print. So so the table is presented in a better format. Yeah, you can see it's neater now this way. So you have the bank name, you have the city where the bank is, you have the state, you have the certificate number, you have the acquiring institution, you have the closing date and fund sort ascending. So you have it's some information. FDIC, I'm sure is an inform is a financial organization. Yeah, Federal Deposit Insurance Corporation. Yeah. So, but I think some banks going bankrupt and some other banks acquiring them. That's what this data is about. So, so with web scraping, you can actually get information like that too. Okay. So let's talk about data formats now. So how is the data structured or encoded, right? So you have different data formats, and some are better than the others because maybe they take less space or they are more efficient to work with. Of course, the most popular we all know will be Microsoft Excel, and that's what I'll be talking about that in the next after the first one. So this first one is the comma separated values. In fact, there's also tab separated values. Somehow, okay, well, I think I can use the same example, right? So here, so let me call this 2.31a, all right? So I can now make the other one 2.31b because they are pretty much the same. They're pretty much the same. Um, so you have comma separated values. So you can just open your notepad and then you write name, comma, age, comma, city, enter. So if you now start Alice, comma, 24, comma, name, automatically and you save it by the time you're done and you save it as .csv, it automatically converts it to a CSV format where it sees that the comma is just like is the line you draw in a spreadsheet, for instance. So that works. So and this is how to load. Okay, well, before I even talk about that, let me create a new cell where I now talk about uh 2.3.1b, and that is TSV. So instead of comma separated, it will now be tab separated. So, and this is a very good way. So I run this now. Okay, this is code. Yeah, this should be markdown, not code. So, so the same thing, except that now you have a simple text file where each line represents a row of data, and tabs and tabs separate the columns. So I make this and I paste what we had before. But instead of comma now, it's a tab. So tab separated. That's why it's tab separated. So I just come here, tab, then this tab. So if you open and you press tab, that's a tab separated value. So if you do this, the tab also automatically makes just the document aligns everything according to the tabs. So interestingly, you load CSV and TSV the same way, loading CSV/TSV. So you load using the same command. You load using the same command. So you don't have to change this. So this here, the read underscore CSV is the same, but inside it can now be whatever, whatever. Okay, you can have this, right? And then you can have if I do this one, then you can have data.tsv. Okay, but you do use the same read underscore CSV to read them, right? So that goes. Of course, this is not this data.tsv is not a proper data. It's just made up. So I can put it in raw, just to it's just for explanation. So if you have a proper data now, you can now put it there and get your results. Okay. So now, of course, the Excel is popular. We know Microsoft Excel. So, I mean, an Excel file with multiple sheets, usually used for storing financial, survey, or business data. And how to load Excel. This is just how to load Excel right here. So I don't have, I have some data I'm going to load later. I'm going to show you about that. I'm going to show you that soon. So you have to load something in C, of course, to load in CSV, right? You have DF. Now, this DF underscore CSV doesn't have to be this. You can call it DF1. You can call it anything you like. It's just if your file name. Then, so this is the key thing now. So the major thing here is this PD. Talking about pandas, because we need pandas to do this. I'm going to talk a bit more about pandas as we move on later, right? But pandas is like the key library for data cleaning, data manipulation, data analysis. Okay, so I'm going to talk a bit more about pandas after now, but this is just like our introduction to data types and everything. But I'm just jumping ahead to give examples of this. But I mean, you can already see. I mean, this will make it exciting that you already have data, and then you can begin to work with those data sets you have. So for Excel, right? So you just have df underscore Excel just to distinguish between CSV Excel and JSON or whatever else you'll be using. So you can just call it DF. You can call it DF1. You can call it DF2. You can call it your name if you like. Just call it a name you can easily identify. So that's why DF Excel helps us to know we are talking about Excel here. So instead of PD dot read underscore CSV like before, now it's PD dot read underscore Excel. So this is standard statement. PD for pandas, read underscore Excel is a function that reads that Excel. Now you can now upload your Excel data here. So if you don't put the sheet name, right? If you remove this sheet name, so it automatically takes the first sheet. But if you want to be specific about the sheet number, right? Maybe you can have one Excel document. That's the beauty of Excel. You can have one Excel document and then it has 50 sheets and you just want to analyze what is in sheet for 38. So all you just need to do is just say comma sheet underscore name equals sheet 38. All right. So it goes straight to sheet 38 and does the analysis. So if you are working with sheet one, you could as well just not bother because by default it's this thing reads sheet one if you don't specify the sheet number. So I don't have any data called data.xlsx. That's why I'm just showing you how to do it. Now this is JSON data now. So JSON, so I mean I think it's some kind of consensus, right? Like CSV seems to be a bit more efficient than Excel, and I think JSON is better, is a bit more efficient than even CSV, and it's particularly good for very large data sets, right? So it all depends on. I mean, I do there are arguments about this sometimes. So it all depends on the level of data. Now, if you get into machine learning, right, where you're dealing with tons of data, then these things can become very important. So a format often used for web APIs, where data is structured in key value pairs, possibly nested. And the content of a JSON file looks like this. So you have name, Alice, age, 24, city, New York. So, and you run that through. So you just keep running that through and with different information like this. So if I click this now, this is what I have. Okay. Well, how do you load JSON data? This is it. Of course, this is raw because I don't have any data called data.json. But we are going to have specific examples where we actually upload real data, right? So now you can also have data in SQL format. That is in structured query language. I think along the line I should do like a playlist on structured query language. I think I'm going to do that along the line. So let's see how that goes. So a very good example would be a relational database format used for storing structured data in tables, where, of course, structured data rows and columns. So if you want to load data from SQL, you need to import SQLite. Now, interestingly, using Jupyter Notebook, we can actually run an SQL, and this is because we are using Jupyter Notebook, and that's why the structure is like this. But if you are using some other platforms, you may not need to worry so much about some of these connect and the rest of them. So we are connecting with the database and all that. So if you want to get data from SQL, this is standard. Connect to SQLite database. So assume the database is example.db. So you just connect to say SQLite 3. So you have imported the SQLite 3, which is the library here. Dot connect with that database, and then query select whatever from user. So you're selecting everything there, and then df SQL now is now PDF read SQL query, comma conn. Then you can now print. So since I don't have anything regarding that now, so that's why I just put it in raw form. So this can actually help you to do an actual thing if you want to do that. Okay, so let's talk about loading data into pandas. Of course, this is just a summary of the possibilities. Up there, I've talked about CSV, I talked about Excel, I talked about JSON. JSON is JavaScript object notation, right? CSV is comma. Oh, okay. Okay, not all the names are here now. So CSV is comma separated values, and of course, Excel comes from Microsoft Excel. So you see CSV is comma separated values, and this is the pandas function to read such a file. You know, in reality, this is how that goes. So where the file is actually whatever the file name is that you're working with. Then you have Excel. It's a spreadsheet format in XLSX. You have that JSON, hierarchical, and web friendly. So if you want to do web friendly stuff, you use JSON. Then SQL is for relational databases. API, that uh I keep forgetting that thing. Programming interface. Application programming interface or something like that, yeah. So where two applications talk to themselves to retrieve data. So like you can talk to X helps you get data about weather, right? Something like that. So, and these are the pandas functions to read them. And then this is how the example, a very good example of that is. So it means you need to get your URL into this place to be able to do that. Okay. Then HTML table extracted from websites. So that's like web scraping where you get information from tables on websites. Okay. So I'm doing some examples here. Now, before I go into this, I'd like you to see the data set. These are data sets I made up for myself. I'm using so I have this okay, let me start with the CSV. So I have this is the CSV. This employee record is a CSV doc. No, where is it now? Scores. Sorry, student scores is a CSV file. It's a comma separated values, as you can see when you point at it. So like most times I always advise that when you get a data set, it's better look at it first in the format in which it comes, like maybe it is Excel, in CSV. Just look at it there first. You may have to do some cleaning up there even before you start doing cleaning up in Python. Of course, you're going to see how we can clean using pandas. So here, if anything goes wrong, you can already correct it. You can just look through in this background. So this is a data I made up. So it's a student record, student ID, the student's name, the age, the gender, the grade level, their score in different subjects, math, English, science, history, and art, like this. So this is what I came up. So we're going to be working with some of these things. And make sure all the names are Nigerian names. So like this. So this is a CSV file. Then I have okay, save. Yeah, no problems. Okay, don't save then. Yeah. So I have a I have an Excel file which is a which talks about customer behavior. So we have customer ID, we have the age of each customer, the gender of the customer, the purchase frequency, the average spending, the loyal program membership, in case we have a loyal program membership. So we want to use this to track the behavior, how customers patronize our business. This is also something I made up, and this is in Excel format. And then lastly, we also have a JSON file. Uh, where the JSON file, where is that now? Yeah, city population. So I have some cities made up. So you can open that using Notepad for sure. So I have a city made up. Yeah, some African cities made up with their children population, youth population, and adults population like that. Okay, so these are the raw files. But so when we get into the Python code now, we have this. So I run this. So it shows us we have so it shows this. But I mean, if you want it neater, you can remove the print. So sometimes you have the liberty to do, especially if the df underscore CSV, instead of saying print df underscore CSV, you can just do df underscore CSV directly, and it just gets. So this one brings it out in a neater format. So here we have, because we have 50 students, and that is numbered from 0 to 49. So everything is showing. So you can see it in a cleaner format like this. Okay. Then for the Excel file now, you can do the same. So df.read underscore Excel, just like we did here, df.read underscore CSV for that. So for Excel, we do what we have to do. So if I run this now, it shows, so you can see it's showing it in a scattered format, right? But if I want it neater, so I just remove the print and then it brings it out in a neater way. The only thing is that the data we have here, we have 70 rows and 6 columns. So it means we have 70 customers with 6 columns. So once it's more than 50, it shows you the first five and the last five. But then you can always you have power over what you want to see or what you don't want to see. We are going to see that so when we talk about head and all that. So for JSON can be done the same way. So we just have pdf.read underscore JSON and city population that I showed you. So it shows you. So this one we have 30 cities. So that's like showing you everything at once. So if you want it neater, you could also just copy only the df JSON out, and then you just have this created and then run, and then it shows you that neat thing. So it add a bit of color to it. So we have all the cities: Zalanga, Kwebura, Domasi, and the rest of them. Okay, so how do we now preview and inspect data? Now that you have your data uploaded, you now want to preview. So there are many things you can do. Once data is loaded, it's important to inspect it for data cleaning and analysis. Here are some useful common data inspection functions. So we have head.end. So this view the first n rows of the data frame. Default is 5. So if you want to see, if I remove this 3, for instance, now, it means I want to see the first 5 rows, right? If I put say 3, the 3 that was there, it means I want to see the first 3. If I put 10, it means I want to see the first 10. Okay. So but the only thing is that this one breaks and then it continues from here. All right. But like I told you, if you don't want to see all these things, so just do df underscore CSV without all the rest. So you can do the same for all the other formats. Then info, if you want to get some information, so info provides a summary of the data frame, including the data types and null counts. So we are going to talk about data frame and all the rest later. So this is just like whetting our appetite. So I just wanted you to be able to hit the ground running. So you can already begin to upload data and begin to play around with it. So this info actually provides a summary of the data frame. It tells you the number of columns. So here we have 10 columns. Don't forget, counting starts from 0 to 9. So we have 10 columns. We have 50 rows. And the data types, student ID is object. So objects can only be classified, but integers can be, you can make calculations with integers, right? So this gives you an idea like that. So when you see objects, you can only group them because you can't do calculations there, but integers, you can do calculations. You can find average and everything. So when we get to exploratory data analysis, you'll come across a function called describe that tells us a kind of statistical overview of the information, and it only works with numbers like integers or floats. You already know the data types in the previous videos where I talked about Python variables, data types, and data variables like that, or data structures, right? Then of course there is shape. Shape tells you number of rows, number of columns, which you already have here, by the way. But I mean, if you want to be more specific about that, so for instance, if I want to know what is in the CSV shape, the student record thing, so we know This will not be 3 by 3. I can always change this. So this is 50 by 100. That means we have, this is, I mean, 50 by 10. This is 50. So it means we have 50 students with 10. So we have, that means we have 50 rows and 10 columns. Okay. So that's what this is about. Then you can also know the number of columns like this by running this. So you just come. So uh, of course, shape returns a tuple of a tuple representing the number of rows and columns. Columns actually displays the column names. Okay, so here just shows you the column name, student ID name. So maybe this is good if you want to do something like feature engineering, as we are going to see as we go, as we continue in this process. I forgot to make this in bold. If you want to do this, just put two double stars, and then that will be bold. And okay, same for D types here. So two stars start, two starts to end, and you run, and it's now bold. Okay. So here you want to see column names, so you can know what you want, what in case you want to use the column names for something. Then if you want to see the data types, of course, this is like overkill because even here we already know the data types. But if you want to know just data types explicitly, you can do that here. All right, so that's how that has been. So you can make up your own data set or uh, all these data sets and even this Python code, this Python file is actually available for download. So you can download that directly and then play with it. In fact, before you start watching the video, any video here, download first and then you can work with this. Thank you so much for listening. So let me know how helpful this video is for you. And if there's a topic you like me to teach, a problem you like me to solve, or you have a data set you like us to analyze, you can send it to me. Of course, I mean, I'm going to do it on YouTube. So if it is something private, so please, yeah, we don't want that. All right. Or if there's an idea you just want me to explore, I'll be open to checking that out. So feel very free. Let me also know. Yeah, I've told you that already. So if you have subscribed to the channel, thank you. If you have not, please go ahead and do that right now. And for everyone, don't forget as you subscribe, hit the notification bell so you can always get alerted each time any video is released. And feel free to like and share so that more people can have access to this great content we have going on here. Till I come your way again, keep doing data right. Bye.